So on this one, we're not going to pay attention to the negative 4. We're not going to worry about the negative 4 till the end. Right, Luis? I'm not going to care about it. What I'm going to do is just simplify the square root of 75 first, and then in the end multiply any numbers by negative 4 that are on the outside of the radical. So let's rewrite rad 75 as something times something else. Can someone give me a perfect square factor? We're rocking and rolling. Look at that. Let me put the negative 4 out here, because that's not going to disappear. It's going to stay with us till the end. And you'll see how it's going to factor in the end. Watch.
So you can't go like 35.5 on it? Like,
what?
Like, no, like, you know how it's 0.5?
Excuse me, just got the 4. Second.
You can't go like 35.5 times 2?
You could, but remember, our goal is to make sure one of these are a perfect square.
Oh, okay.
So that wouldn't help, even though you technically can. It's not going to be helpful, though. All right, negative 4 times, I'm going to separate these puppies. Rad 25 times rad 3, yeah? See, once I get the perfect squares, I separate them. And that's going to allow me to write it in simplified form now. Here we go. Negative 4 times 5, this becomes 5 times rad 3. And now I can multiply normal numbers times normal numbers. Notice that, right here and here. What is negative 4 times 5? Thank you. So our final answer is negative 20 rad 3. We're rocking and rolling. That's it. 1 second. Good. Here's why. You can't break down rad 3. There is no perfect square factors of rad 3. That's when you know you're done. You can't break it down any further. In other words, none of these numbers fit into 3, right? Lozano, question? Go ahead.
How does it count simplified?
No, because that's just a normal number, huh? If it was square root of 20, yeah, but that's just normal negative 20. There's nothing to do with this. Normal negative 20. Good question. One more. Last one. 7's a good number. 7's a number for completeness. No, we just did 6.
Skip 5.
We skipped 5?
Oh, no, you counted the one with that's 5. So,
Can we do another one like 6?
Yes, that's exactly what I'm going to do. So this will be 7. 20 times the square root of perfect square. That's a perfect square though. How about this one? 80. 20 times the square root of 80. Okay, Lozano, hit it.
Does outside number always stay the same, or?
Right, it stays with you till the end, and then you can multiply by any normal numbers in the end, like we did on example 6. Look at the negative 4 stayed with us all the way to the end, so I was able to multiply by the normal number of 5 to become negative 20. So normal numbers you can multiply as normal with normal numbers. Radicals can only be multiplied by other radicals. See, look at a radical times a radical became this. It becomes radical 75. What's a perfect square factor of 80? I like it. Rad 20 times rad times 4. Let me put the 20 out here. Notice how one of these is a perfect square, namely that one. That's a perfect square. I'll put PS. Luis, you're not taking notes? Okay, why's the screen on? Can you shut the screen? YouTube Burns, shut the screen. Thank you, you're awesome. So watch this. 20. Let me split these puppies up. Times rad 20 times rad 4. This is not a perfect square. That is a, huh? So what does this become? 2, huh? So I got 20 times 2 times rad 20. That becomes 40 rad 20. But let's not get all excited. We still got to break down rad 20 because I know there's a perfect square factor in it. If you know there's a perfect square factor of the number, then you got to keep breaking it down. So you can't do it anymore. What's a perfect square factor of 20? 4 is, and then 4 times 5. So watch this. 40 times 4 times 5. That's a perfect square. I'll put PS right here. There's your perfect square. All you got to do is make sure one of them's a perfect square. You factor it. Let's keep going. So this is really then 40 times rad 4 times rad 5, which is really 40 times 2 rad 5, because the rad 4 became 2. So we got 80 rad 5, huh?
How do we produce in the calculator?
Like getting that answer? No. When you type in this into your calculator, watch that. It'll give you to the infinite irrational decimal.
I see that.
Sure.